Good morning. Welcome to our notes for section 10.6, parametric equations. Parametric equations are groups of equations. For us, they're going to come in pairs that relate three or more variables. Parametric equations are often used in representing particle motion in physics, and in that case, that third variable would typically represent time. And for that reason, the way we have it laid out here, our textbook uses t as this third variable. In this section, we'll take models with two variables, x and y, and introduce this third variable called t. So for example, a graph could relate your x value, the horizontal position, to your time, right? If you throw a ball, maybe you're in physics class or something and you throw a ball, then you could relate the horizontal position of the ball directly to the variable time. But you could also relate y, the vertical position, to that same time. So with parametric equations, we calculate in graph coordinates x, y, where each of those are themselves generated by some function of t. So you want to think of your coordinate not necessarily as just a point, a value and a value, but as a function and a separate function with relation to this third variable. A lot of applications would work this way. Here we have our definition of a plane curve. If f and g are continuous functions of t on an interval I, then the set of ordered pairs f of t, g of t is called a plane curve C, and the equations would be x equals f of t and y equals g of t. That corresponds to that piece of the definition here, and essentially is just giving you this piece just written in a different way. We call these parametric equations for some curve C, and t is called the parameter. There's not a vocab quiz here, but you want to be able to understand directions and things. If I tell you that I'm handing you a set of parametric equations, or I define the parameter a particular way, you need to understand how these things relate to one another. The parameterization of a function is not unique. So you could have the same function parameterized different ways. You can get the same sketch using different sets of parametric equations. Let's talk about how to sketch parametric equations. There are a couple of methods, and then the reality is that you typically sort of do a mix and match of both of these, depending on the curve. So the first example is just to plot points. You guys are used to generating, when you first meet plotting functions, you typically just pick x values, plug them in, and then find the corresponding y and plot your points. It's not going to look that much different, except here, because we have that third variable, our t-chart will be a bit longer. So here, we're going to choose not our x or our y value, we're going to choose our t value, and then we'll generate the coordinate that should go with it. Now, a tricky part of this can be, well, how many t's do I need to choose? Just like when you're graphing a line, you know that you should choose 2 points. When you're graphing a parabola, you find the vertex and maybe 2 more. Think about when we did the ellipse, right? We had a particular set of points that we were looking for to help us define the shape. And so it can be really tricky to understand what are good values for t. Typically, right, like if I'm doing a line and a line, then I don't need to get too creative. If I pick enough points, I should have a general shape. So I'll show you here by choosing -2, -1, 0, 1, and 2. It gives us the 0. It gives us a little bit of positive, a little bit of negative. So it gives us an array of selections for the t value. And then in order to generate my x value, I'm going to take each of those t values and plug them into the x equation. So when t is -2, x is -3. When t is -1, right, I subtract 1 and I get -2. If you think about it, this is a linear function, right? I should be going up 1 every time. So 0 minus 1 is -1, I'll have a 0, and 2 minus 1 is 1. You can either plug it in or you can use properties of linear functions. Then I would go ahead and fill in the last column, but this time I'll get my y by plugging in the t value to the y equation. So 3 times -2 makes -6. -6 plus 1 is -5. -1 times 3, that's -3. Plus 1, that's -2. Notice you're going up by 3, which you would expect because this is a linear function. So 0 plus 1 is 1, and I'm going up by 3, I'll get a 4, and I'll get a 7. Now, when I go to graph, I'm only going to graph in what looks just like our XY plane. I use my thumb tool here. So I'm going to graph in what looks just like our XY plane, and I really only graph the X and the Y values. And I'll show you in a minute what to do with the T values. So when you graph, you're only going to graph just like you normally would, and basically ignore the T. So -3, -5, 1, 2, 3, 1, 2, 3, 4, 5, right about here, -2, -2. All right, I'll stop talking out loud. And 1/7 is going to kind of fall off, so we'll leave that one off. And I'll connect the dots. I can see that these are roughly a linear function. And I had 2 linears and I got a linear out of it. Now, what do I do with the T? That is this piece at the bottom about sketching orientation. We're going to choose 2 different values for the parameter. So for example, 0 and 1. And we would draw arrows to show the direction that the curve moves as T increases. So let me grab a different color here and we'll do some labeling. When T was 0, right, I obtained this point right here. And as T increased to 1, I moved to this point right here. So I can say that the behavior of this graph is moving from left to right. As T increases, right, I am moving in that direction. And I use these direction arrows. I want to make them nice and thick so that they stand out against just my regular lines to say that this line goes on forever. I want to set those orientation arrows so that the T sort of shows up in my graph. And that is a nice complete graph where we are sketching a parametric equation by plotting points. So here's another one. Go ahead, you could turn it off and give it a try. The steps are exactly the same. You have your T values, you're going to generate your X, you're going to generate your Y. Here, right, same thing. I might choose -2, -1, 0, 1, 2. I even chose an extra one. If I'm looking at my notes, must have needed it just to get an idea of the shape. Oh, sorry. Look, here it says that my interval is from -2 to 3 exactly. So I'm only including these values when I sketch my orientation. This one won't have arrows on the end. I'm going to go ahead and do the same steps I did before, right? I'm going to plug in each of those values. So I end up getting -2 squared, that's 4, 4 minus 4 is 0, and I plug in -1. I'm going to go ahead and just fill in the chart rather quickly. All of these values are just from plugging the values in to the original function. And likewise here, I'm plugging into the T over 2. So I'll get -1, -0.5, 0, 1/2, 1 3/2. And same thing, I'll go ahead and I'll plot my points. Right? I'm only, again, plotting the X's and Y's as listed, and I'll take care of the T's with my orientation arrows. So 0, -1, -3, 1, 2, 3, right about here, right about there. Nobody's correct me, right? 0, -1 belongs right there. I noticed my symmetry was off. And 5, 1, 2, 3, 4, 5, up 1.5. Right, this one, I don't want it to go on forever since my X's, or sorry, my T's are so narrowly defined. It would only be between here and here. And if you think about, the first point we plotted was right here, and the second point we plotted was right here. So as T increases,